a second example of finding volumes using the shell method. We begin with these equations that designate a region to be revolved about the line x equals 4. So we've got a line, and a line. I've already graphed these. So I'll start off with the y equals 1/2 x plus 2. That's this line right here. Second equation, I've got the line y equals x. So that's this one right here. And then I've got the x equals 0. Well, x equals 0 is just the y-axis. So I have this triangular region right here. I know that the points intersect at x equals 0. That creates this boundary. And x equal 4 would actually be this boundary. So when I set up my integral, I say the volume is equal to 2 pi. I'm going to start at 0 and end at 4. So it's x equals 0 to x equal 4. And because it was around something like the y-axis, parallel to the y-axis, I know that I want everything to be in terms of x. That's the beauty of the shell method. Because traditionally you'd want everything to be in terms of y if it went around the y-axis or something parallel to the y-axis. Since I'm using the shell method, it says that I can keep everything in terms of x. So I had 2 pi. Now my radius is defined as me standing here at 4, and I move to the left. As I move to the left to establish that radius, it'd be 4 minus x. So I go 4 minus x. I'm at 4, and I need to go to this direction. So that's where I'm getting my 4 minus x. And then my height would be the top curve minus the bottom curve. So it's 1/2 x plus 2 minus x. That's what I have here. On the next line, I simply combine like terms and reduce the equation that I'm working with. So I got the volume is 2 pi, the integral from 0 to 4, my radius of 4 minus x. That's all contained on this quadrant. So I'm allowed to go 4 minus x, staying in that same quadrant, same region. And then top curve minus bottom simplified to 1/2 x take away x, negative 1/2 x plus 2. Now I can put that in a calculator. Well, here's my calculator. I'm simply going to type what you see. So I go y equal, I got 2 pi, I'm going to say 4 minus x, and then this part becomes negative 0.5x plus 2. Negative 0.5x plus 2. Okay, so I agree with everything I have in there. I go second calc. I'm doing everything on the calculator. These can be done by hand. I'm just showing the quicker way. I'm more interested in setting up the integral than anything else. So I go to option 7. It'll graph. It's asking for my lower limit, which is 0, the upper limit, which is 4, and it's given me a value of 0.67021. And so that gives me the area using that shell method. If I keep pointing to the radius because that's the question everybody keeps asking about, is how do I set up that radius? It's my axis of revolution plus or minus x depending on where I'm at. It also depends on this region. So I've got to watch that region, make sure that I'm not going over to the other side of the y-axis, because that will slightly change the setup. And so now we've got a setup here. Here's our 2 pi, radius 4 minus x, height, and then the width of each shell. There's 2 examples on how to set up the shell method.